Hello, in this lesson, we are going to talk about comparing sides in a triangle. So in example 1, it tells us to draw an obtuse scalene triangle. Remember, obtuse has one obtuse angle, and scalene just means all the sides are different lengths. Then it says to mark the largest angle and longest side. What do you notice? Well, if I'm looking at my triangle here, the largest angle is definitely going to be the obtuse angle. And if I look across from it, it is going to be across from the longest side. So I notice that the largest angle is across from the longest side. And it works the other way too. Your smallest angle, and unfortunately it's kind of hard to tell which one, but I'm suspicious this one's going to be my smallest one. Your smallest angle is going to be opposite your smallest side. The shortest side. Also, if you are watching and listening to this video, please write the word red panda on the top of your homework and show Mrs. Lannert. Thank you. All right, so the next one, so there's a theorem that goes with this, okay? It is literally called the triangle longer side theorem. So if one side of a triangle is longer than the other side, then the angle opposite the longer side is larger than the angle opposite the shorter side. And then it works the other way too. It works when you have angles. So in this triangle here, angle C would be larger, greater than angle A. When you're dealing with triangles, the sides and the angles opposite them have a direct relationship. And it works the other way too. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So it works with angles too. If this angle is 50 degrees, the side opposite the 50-degree angle is going to be bigger than the other side. So we would say BC is larger, greater than AB. Okay? So practicing this, you're going to have to order the sides of your triangle. So if they give you sides, it means they want you to list the angles in order from smallest to largest. So we'll start with the smallest side and then go across to find the smallest angle. So LK is my smallest side, and if I go across from it, I get to angle J. That is my smallest angle. Now I go to the next biggest side, which is 16, which is IJ. And I go across from IJ to angle K. And then my last side is my biggest side, that's 18, which is KJ. And then I go across from it to angle I. And that's my answer. I put my sides in order. So then we'll do it with this one too. We're going to go to the smallest angle, which is going to be across from the smallest side. So we would say angle L. Then we're going to go to the next biggest side, which is 18. Across from that is angle M. And then we go to the final side, which is 20. Across from that is angle K. And then last, we're going to go again to our smallest side, which is 17. We go across from that, which is angle X. Then we get to the next biggest side, which is XY, so that's angle W. And then our final side, which is 20, that goes across to angle Y. So we go smallest to biggest. And just remember, it's the angle, the one that's not touching the side that you're talking about. And it works the same way with side lengths too. The bigger angle is across from the bigger side, but they want us to go shortest to longest. So my shorter angle is definitely going to be the 55, I should say smaller, 55. And we go across from that and we get to side GE. Remember, you could also say EG. Then if I keep it going, I'm going to go to the 62. That is the next biggest angle. So the side across from it is GF. And then my final angle is 63. Across from that is FE. Next triangle, my smallest angle is 36. So across from that is angle side LM. My next biggest angle is angle M across from that. Now this can be kind of tricky. Just remember you're looking for the side across from it. So that would be LN. And then last, we have the 98, and across from that is NM. If it's getting confusing, I really recommend trying to highlight each angle and side that match like I'm doing. Smaller angle is 48. Across from that is FD. And now this one's kind of interesting because the next biggest angle could be either angle, D or F. Across from angle D is EF. And then across from angle F is ED. So either one of those could go next because they're actually the same angle. Okay, so finally, we're going to learn about a way to check if you can make a triangle. Okay. The sum. I was trying to think of what goes in here. So the theorem that's going to check if we have a possible triangle is called the triangle inequality theorem. So we would say the theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So when you add the side lengths, they have to be bigger. They cannot be equal to the third side. And we're going to test that. So just an example. In this example here, if I add side AB plus side BC, that would have to be greater than side AC. And then I could add BC plus AC, and that has to be greater than AB. And then AB plus AC would have to be greater than BC. So all of those have to happen in order for it to make a triangle. So in this one, a triangle has these are kind of interesting. So a triangle has one, I'm going to sketch it out because geometry just really lends itself to being sketched out. So one side length is 14 and the other side length is 9. Now there's only going to be two ways to kind of check the length of the other side because because you'll see, that's just the way the math works. You only have to check 2 situations. So first we're going to treat it like it's the shortest side. Then we're going to treat it like it's the longest side. It really doesn't have, you don't have to worry about it being the middle side, and you'll kind of see why. So we'll first treat it like it is going to be the shorter side. So we would say x plus the side we don't know plus that 9 is going to have to be greater than 14. So if we subtract 9, we're going to find out that x would have to be greater than 6. No, 5. Than 5 in order for this triangle to work. So far that's one of the qualifications. Now we treat it like it's the long side. So we would say, well, what if x is your biggest side? So then that means the 9 plus the 14 is going to have to be greater than that other side. So then we would say x has to be bigger than 23. Now, mathematically, we don't have to, it doesn't matter. We don't have to go, we would not have to pretend it's a middle length side because it doesn't make sense. 14 is already bigger than that 9. So we're not going to create an equation that says x plus 14 is greater than 9. That doesn't make sense because it's not true. 14 is already big enough. So we don't need to worry about that. So this tells us that x would have to be both greater than 5. Excuse me, I should put the lower number on the left side. We always try to follow that number line, friends. So x would have to be bigger than 5, but less than 23. And you can write it separate too. So either one of those, okay? And last, we just got to check and make sure we've got a triangle. Oh, there's our bell. So we're just going to check it. We're going to see if these could make a side according to that theorem. So we're going to go 7 plus 5. Is that going to be bigger than 4? And we would say, yep, 7 plus 5 definitely will be bigger than 4. Then we're going to go 7 plus 4. Then we're going to go 7 plus 4 and see if that's going to get us bigger than 5, and that one is. And then finally, we're going to go 5 plus 4 and see if that gets something bigger than 7, and that also works. So we would say, yes, this is a triangle because of the triangle inequality theorem. It fits that theorem. Then, hello guys, then we're going to check the other one. We're going to go 3 plus 6 and see if that gets us something bigger than 2, and that one would. Then we'll keep it checking. We're going to go 6 plus 2 and see if that gives us something bigger than 3. I'm almost done, you guys. And then we're going to check the other ones. We're going to go 2 plus 3 and see if that gives us something bigger than 6. And these guys work, but this one does not work. 2 plus 3 is 5. 5 is definitely not bigger than 6. So we would say no, does not fit the theorem. And last, we're going to check these guys. We're going to go 5 plus 2. Is that going to be bigger than 4? Yup. 2 plus 4. Is that bigger than 5? Yup. And then 5 plus 4. Is that bigger than 2? Yes. So we would say, yes. This makes a triangle because it fits the triangle inequality theorem.